Hey everyone! Welcome back to Science Explorers. Today, we're diving deep into something we all experience every day, but might not fully understand. That's right, we're talking about temperature, thermal energy, and particle motion. Before we jump in, let's quickly review something important. Everything around us, solids, liquids, and gases, is made up of tiny particles like atoms and molecules. These particles are constantly in motion, even if we can't see it. The way these particles move plays a huge role in temperature and thermal energy, so let's break it all down. Let's start with temperature. When we say something is hot or cold, what we're really talking about is the temperature, which measures the average kinetic energy of the particles in an object. In the hot beaker, particles are moving super fast. In the cold one, they're moving much slower. That's because temperature tells us how fast the particles are moving, on average. It's like a dance floor. If the dancers' particles are jumping and spinning wildly, it's hot. If they're barely swaying, it's cold. Now let's move to thermal energy, which is not the same as temperature. Thermal energy is the total energy of all the particles in a substance. Even if two objects are the same temperature, the one with more mass, or more particles, has more thermal energy. Think of it like this. Temperature is how fast each dancer is moving. Thermal energy is the total energy of all the dancers on the floor. Let's zoom in again and look closely at particle motion. In solids, particles vibrate but stay in fixed positions, kind of like people standing still but bouncing in place. In liquids, particles move more freely and slide past one another. And in gases, particles fly around in all directions at high speed. When we heat something up, the particles start moving faster and farther apart. That's why solids can melt into liquids, and liquids can boil into gases. Let's see how this all works in real life. When an ice cube melts, it absorbs thermal energy from the air. That energy speeds up the motion of the water molecules, turning the solid into a liquid. In a car parked in the sun's energy increases the temperature inside the car. The molecules in the air and surfaces move faster. That's why it feels so hot. When you cook, heat transfers from the burner to the pan to the food. The particles in the food move faster, raising the temperature and changing its state, like boiling water or melting butter. Okay, let's review. Temperature, average motion of particles, thermal energy, total energy of all particles. Particle motion, how particles move, fast in heat, slow in cold. Heat transfer, moves from warmer objects to cooler ones. All these ideas are connected and they help explain everything from weather to cooking to how refrigerators work. Science is everywhere, and now you understand a big part of how the world works. So next time you sip hot cocoa, microwave popcorn, or feel the breeze outside, remember the tiny, invisible particles moving all around you. Thanks for exploring with us. Don't forget to like, subscribe, and share if you learned something new. Stay curious and keep on learning.